We're now, okay, chapter one dealt with linear equations. Y equals mx plus b. Chapter 2, we started getting larger. Then we started doing transformations, moving things around. All of the functions, library functions. Chapter 3 dealt with quadratic equations. Now comes polynomials. Linear equations look like this. What's their degree? What's the degree of a linear equation? 1. The degree is the exponent of x. Quadratic equation. Ax squared plus bx plus c equals 0. The degree of that one was 2. Cubic equations. They have a degree of 3. And then we go to quartic and everything like that. These equations are all in the family that are called polynomials. Okay, if we look at this, that's called a binomial. Why is it called a binomial? Only 2 terms. This is called a trinomial because it only has 3 terms. Quadrinomial because it has 4 terms. Instead of writing all these other ones, we just call it polynomial. What does poly mean? Is that? Many. Polynomials, many terms. We are no longer restricted to the size of equations we use. They could be any size, any degree. So polynomials look like this. That's a polynomial of degree n. We're going to be able to solve these. At the end of this chapter, well, we'll cover that in class, whether you're able to solve it, I don't know, when you do the homework assignments. This chapter, I strongly suggest do not slack on. Do the homework the day we do the topic. Even if you didn't do chapter 1, 2, or 3 yet. Those are Mickey Mouse compared to this. This is the one's going to blow, that's going to make you fail. Because now I'm going to get, there's so many moving parts here that you have to stay on top. So that's a polynomial of degree n. Why is it called a degree n? Because that's the largest exponent. Let's look what happens here. It's that I give you a function. Let's use this simple one here. We've done these in the past. So what can you tell me just by looking at this? Okay, it's a trinomial. You tell it's also it's quadratic, but it's squared, yes. But no, I want some substantial stuff because we're going to graph these things. We're going to solve these things. What's that? Oh, what is the vertex then? What is it? I want a value. I don't want location. Since we have an equation, I don't want the definition. I'm done with definitions. I want now values. No. Why would you say one? Isn't a vertex a point? How'd you get zero? How'd you get one to begin with? No. What is the x value of the vertex called? The axis of symmetry. What's the formula for it? Very good. Negative b over 2a. Where did that negative b over 2a come from? It came from the quadratic formula. Because if that's zero, then we have negative b over 2a. That's the vertex, the x value of your vertex. Once you find that, to find the y value, you plug that back into the equation. Again, that's what chapter 3 is about. Again, had you done your homework assignments after we talked about them in class, this stuff would not be first time knowledge to you. What else can you tell me about this by looking at it? Okay, do we have a max or a min? Why? Because a is positive, a is greater than 0, is 1. It opens up. So we have a minimum. Very good. We can calculate the vertex. Label A, B, and C. 1, -2, -3. We can plug it in there. Negative of -2 is 2 over 2 times 1. So we have a positive 1. Plug in 1 inside here. 1 minus 2 minus 3 is -4. So that's my vertex. Again, I'm going fast on this because we've done this a whole chapter of this. At least I did. I don't know if what you all have done so far. That's the stuff we covered last chapter 3. What else do we know? What else can we figure out? What else do you need to graph it? What's the y-intercept? Is what? There you go. 0, -3. Because it's the constant. Okay, since we have a y-intercept, how do we find the x-intercept? And then what? I can't say solve. How? We've just went through 3 different methods of solving it. How? Which method are you going to use? Oh, we just talked about one method, use the quadratic formula, or we can factor it. What signs go in there? Opposite signs, because the second sign is a minus. And out of this, since the first sign's a minus, the bigger number goes there. So what numbers go inside there? Chapter 3. How do we solve it? How do we factor this? Take the first and the last numbers. 1 times 3 is 3. What times what equals 3? That when we subtract them, we get 2. Three and 1. You can't do 1 and 3 because 1 minus 3 is -2. So 3 and 1. Since 3 is bigger, the 3 goes there, the 1 goes there. These are my factors. What do I do next? I set them equal to 0, and I get my answers. Those are my solutions. They're also called my zeros. Why are they called zeros? Not when x equals 0. That's when what equals 0. Well, let's see. So our answers are -1 and 3. Our function is x squared minus 2x minus 3. I'm calling these my zeros. If I put these in my equation, so -1 squared minus 2 times -1 minus 3. What is -1 squared? Right, 1. Negative times negative is positive. 2 times 1 is 2. It equals 0. That's a 0. It's the x value that makes my answer 0. Those are my solutions. Zeros are solutions. Same thing here. 3 squared, 2 times 3 minus 3. 9 minus 6 minus 3. Those are my x-intercepts. If I plug my value in, I get 0, which is exactly what I want from an x-intercept. Again, all this stuff is it's rehashing what we talked about for the last 2 chapters. Now you see the importance of why I'm begging you to do some work in this class. I'm going to stress this. If anything goes wrong with the system the last week of school and you can't finish, too bad, so sad. I'm going to put zeros in everything you haven't finished. I don't care if the system goes down. You can do it now. You can do it now. You just chose not to. You should be finished at the end of this week. You should be finished with, all the way up to chapter 3 and part of chapter 4. So if anything happens and you can't finish the course, you can't get on the computer in the last week of school, too bad. If you haven't done anything, that's not my fault. Am I perfectly clear? Am I perfectly clear? Does everybody understand what I'm talking about? If you try to do your work in the last week of school and you get kicked out and you can't get back in for whatever reason, your computer breaks, the internet's broken, my math lab's not working anymore. Too bad. My grading will be easier then. I will not give extensions. No extensions will be granted, period, for anyone. So what are polynomial functions? Polynomial functions are functions whose graphs are smooth, continuous, do not have breaks, jumps, holes, or corners. Is that a polynomial function? Not continuous. It stops right there. So that's not a polynomial function. How about this graph? What's that? Nope. It's got a corner. We just said there are no corners. It is a function, but it's not a polynomial function because it has a corner. In other words, it cannot have points, it cannot have corners. This example here is also not a polynomial. It's a function, yes, but not a polynomial function. What function is that? What function is this one? Oh yeah, we have to have a quiz this week. I reserve any day of the week I have that quiz over these functions. This shows me you guys didn't study your functions yet. What is that function? What does that mean? Yes, you read pretty good. This has to be put to memory. Everything else that we talked about is a function. Let's see some examples here. Sheets. Here I have 4 functions and 4 graphs. Match them. What part of a function do you look at to tell the graph? Well, that's one thing. Look at the number on the back. The whole leading term. The leading term tells us a lot. We talked about it for the last 2 chapters. The behavior, the leading term, the end behavior chart. So what do we know about this one? What's the degree of this one? The degree is 4. It's even. The leading term is positive. What does that mean? It points the same direction and it points up. So which out of these 4, which one's same direction points up? That's number 1. And it crosses at 3. So this is D. How about B? What do we know about that one? Yeah, the y-intercept it is important, but in the very, very lowest scale possible. This is much more important right here. What degree is it? What does that mean? What's the graph going to look like? Well, yeah, it means both ends point in different directions. Because it's odd, they point in different directions. Since this is negative, right-hand side points where? Up or down? Down. So we know that the right-hand side goes down, the left side goes up, and it crosses through 2. Right-hand side goes down, left crosses through 2. So there you go. This is B. This is number 2. Letter C, it's an odd exponent, so they point different directions. Leading coefficient is 1, so it's positive. It means it goes up and it crosses at 1. The only one that matches that is A. So this is A. It's even, so they both point the same direction. It's negative, they both point down, and it crosses at where? Where's the y-intercept? Nope. Is there a constant? Yeah, it's 0. So it goes through the origin. So this is number 4. It goes through the origin. Both ends point the same direction. They both point down. Just by looking, we did 0 math. We just did observation, and we could do that much already. Example 2. Here is your polynomial. Determine whether 2 and -5 are zeros. So how do we do that? How do we determine if these are zeros of this polynomial? Nope. Nope. We just did it a second ago. How do we know if they're zeros? We just did it back here in this example. How do we know they're zeros? In your notes, you should put what defines a zero. But what are you going to write? You pick up your pen. But what are you going to write? How do we know that -1 and 3 are zeros? What did we do in this example? What do we do with them? Hello? Anybody out there? Plug them in and they equal 0. Yes, that's why they're called zeros. If I plug in these numbers into the function, they give me 0. Hence, they're zeros. So put that in your own words. Now, how do we check this one out? And tell me if they're zeros then. Plug them in. See what happens. Pretty large. So the first one, we plug in 2 in the first one. What is 2 to the third power? 2 times 2 times 2 is 8. 2 squared is 4. 17 times 2 is 34. 8 plus 4 is 12. 12, they're both positive. 12 plus 15 is 27. 27 minus 34 is -7. So is 2 a 0? Nope. 2 is not a 0 because it didn't equal 0. We do the same thing with the -5. -5 cubed, -5 squared, 17 times -5 plus 15. Negative cubed is negative. 5 times 5 is 25. 25 times 5 is 125. Plus -5 squared is positive 25. Negative and negative is a positive. 17 times 5 is 85. Plus 15. So we have -125. 25 plus 85 is 110. -110 plus 15 is 125. Minus 125 is 0. So yes, -5 is a 0 of our polynomial. That's how you test if it's a 0 or not. So the question is, where do zeros come from? Where do zeros come from? Zeros, we have a polynomial. The first thing we do, we factor it out. So this polynomial factors out into x plus 3, x plus 1, x minus 2. Those are the factors. Once you have the factors, then you set each factor equal to 0. And whatever makes them 0 are my zeros. These are the zeros. Because they make the answer equal 0. It would make this equal 0. You know, making any sense? What's that? No. Once we factor it out, we solve for set them all equal 0. Those x values, those are zeros because when we plug them back into the function, they equal 0. That's what a 0 is. Find the zeros of this polynomial. If you notice, what do you notice about the first line? You have x minus 2, x minus 2, x. They all have the same answer. So all you have to do is take these two numbers and set them equal to 0. And we learned from chapter 1, if it's inside the parenthesis, it's always the opposite. So if we have x minus 2, the answer is positive 2. X plus 1, we have x negative 1 is the answer. Those are my zeros. So the question you should ask, what's the difference between these two? Nothing. This first line and the second line, there's nothing different. Just the way they look. The second one is a lot easier to determine what's going on. What would the graph of this function look like? What's the degree? No. What's the degree? The degree is the maximum, the highest number of x, right? And for this one, it's 3. But is this factored? If it was factored, what would it look like? It would look like this, right? So x would be in front of each one of them. So there's 1, 2, 3. That's where that came from. So how many x's do we have here? We have 4. So the degree is 4. And it's also, we can count 1, 2, 3, 4 x's. But down here, we do the same thing. This 3 here tells us that this number repeats itself 3 times. This one has a 1, it only repeats itself once. If we add 3 plus 1, what do we get? The degree. These numbers here are called multiplicities. These are called multiplicities. The sum of your multiplicities equals the degree. The multiplicity is how many times that equation, that factored equation repeats itself. So looking at this, what's my y-intercept? We know the x-intercepts already. What are the x-intercepts? 2 and negative 1. We solved those already. What's my y-intercept? This is where it's important. How do you find the y-intercept? What do you do? Set x equal to 0 first. To find the y-intercept, set x equal to 0. So we have 5 negative 2 cubed plus 1, or times 1. Negative 2 cubed is what? Negative 8. Negative times negative times negative is 8. Negative. 2 times 2 times 2 is. So all this multiplied together gives us negative 40. So that's my y-intercept. The y-intercept is at negative 40. My x-intercepts are at -1 and 2. What's the graph going to look like? What's the end behavior? The degree is 4. So what do we know about both ends? Same direction. Are there any coefficients of x that are negative, or is the front end negative? No, they're all positive, so A is positive. So we know from here and here, the graph goes up. So the graph will look something like this because it's a fourth order equation. It says it's degree 4, we have 3 vertices. 1 vertice, 2 vertice, 3 vertice. Let's look at example 4. What's the degree of this equation? Yeah, 2 plus 2 is 4, and there's 4 x's. Is A positive or negative? Negative. There's a negative right there. Because the x's are positive, that's good. But the negative here makes it negative. So what does that tell us about our graph? They both go the same direction, they both go down. What are my zeros? Yeah, it's x equals 1, x equals -2. Those are my zeros. What's my y-intercept? What's my y-intercept? The zeros are also my x-intercept, so I'm done with those. What's my y-intercept? How do you find the y-intercept? Let's repeat this again. Write this down in your papers again. I know you never look at them, but let's do it again. How do you find the y-intercept? What's the step? Set x equals 0. Step 2 is solve for y. So if we set x equals 0, what do we have left? What does that give us? What's our final answer? -1 squared is what? +1. 2 squared is 4. So it's -4. There's my y-intercept. It's not rocket science. Our graph goes down from both of these. I know my graph does this. How do I know my graph does that? No. Close though. It's another purpose of the multiplicities. Remember this in example 3? You notice these are both odd. What happened to those x-intercepts when they're odd? The line goes through them. If the multiplicity is odd, at that intercept, the line crosses. If the multiplicity is even, then it bounces. We've seen this before. These are the multiplicities. What does this graph look like? It bounces off 0, which is my 0 is 0. It bounces. What does this one do? It crosses at 0. So if it's odd, it crosses. If it's even, it bounces. That down. If multiplicity is even, then the graph bounces off the x-axis at that 0. If it's odd, then the graph crosses the x-axis at that 0. We've learned to factor binomials. We've learned to factor trinomials. Now we're going to learn a method that sometimes works with quadrinomials. In other words, equations with 4 terms. This method is called grouping. All right, example 5. This is going to look at grouping. Using grouping. What grouping tells us is take and put parentheses around the first 2 terms. And then put parentheses around the second 2 terms. If the middle sign is a negative, then include it in the parentheses. Else leave it alone. In other words, if this was a plus, if that was a plus, then we'd put a parenthesis around the 9x and 18. But since it's a minus, we put it inside there. So that's my first step. Put parentheses on the first two numbers and the second two numbers. Now, factor what you can. Can anything factor out of the first one? Hello? Can anything factor? In other words, are there anything the same in the first two terms? What's that? How many x's? This is 3, I'm sorry. Yes, they have x's. How many x's do they have the same? This one does not have 3 x's. They both have 2 x's. So if I take away 2 x's from the first one, I have that. I take away 2 x's from that one, I have that. Again, chapter 3, factoring. It's important to catch up with this class. How about the next one? What do they both have in common? Since the first term is minus, we have to take out the negative sign. What else do they have in common? They both have a 9 in common. If we divide by -9, divide by, no, so we took out the negative, we got to change the signs. 9 cancels, so we have x. Change the sign, 18 divided by 9 is 2. Again, chapter 3. If you did chapter 3, you know what I'm talking about. If not, you're in for a rude awakening. Repeat the process. Now we only have 2 terms. What do they have in common? They both have an x minus 2. So if I take out the x minus 2, what do I have left? I have the x squared minus 9. How many answers are we supposed to have? 3. So far, we only have 2 zeros. Well, we can go further because this x minus 2, this x squared minus 9 can be factored out further. It's called the difference of 2 squares. So those are my factors. Well, let me tell you. If you have 2 terms that are perfect squares with a minus between them, you can factor those out to be a plus b, a minus b. That's factoring difference of 2 squares. So if we had x squared minus 9, that's the same thing as x squared minus 3 squared. So it's x plus 3, x minus 3. Again, this is the third time we went over the same rule since chapter 3. And we have other rules for a cubed, b cubed. If you have 2 numbers that are separated by plus or minus, and they're both cubic numbers, the first parenthesis is what's under there already. A plus B, A minus B. In the other parenthesis, it's going to be the opposite sign. Both of those multiplied together plus the last one squared. So it's going to be the A squared. Opposite sign is that one. It's going to be a plus AB plus B squared. Those are the factor of different, these are the sum and difference of two cubes. So these are rules of factoring that when you see those. So since we have x minus 9, x squared minus 9, we know 9 is a perfect square, so we can factor out to be x plus 3, x minus 3. Which just brings us back down to our equation. So what are my zeros? If I get these factors, then what are my zeros? +2, -3, +3. Yeah. Just set each one of these equal to 0 and solve. So these are my zeros. How about this one, example 6? Does that look familiar? It's quadratic. So since it's quadratic in form, how do we know? It's only got 3 terms. 2 terms have x's, and this middle term times 2 gives me the first term. It's quadratic in form. So we can either do factoring or we can do the quadratic formula. If you do the quadratic formula, you're solving for the middle x. So you would have to do x squared equals negative b plus or minus b squared minus 4ac over 2a. You remember, you're solving for the middle x, so you have to solve for this. That's if you're using quadratic. But you can also factor this one. What times what is 45? When you subtract them, you get 4. 9 and 5. Again, where's that little multiplication sheet I gave you all? So if you don't know your multiplication table. So what would go in this first spot here for factoring? You're always solving for the middle term, so it's x squared. The second sign's a minus, so it tells us the signs are opposites. Which sign does a bigger number get? Since the first sign is positive, the bigger number goes there. So what times what equals 45? That when you subtract them, you get 4. Subtract it because the second sign's a minus. And we figured out 9 times 5, 9 minus 5. So 9 goes there, 5 goes there. Now we take both of those, set them equal to 0, and solve. How do you solve these? Move the first one, subtract 9 from both sides. So we have x squared equals -9. How do you solve for x? Square root both sides. So x is equal to plus or minus. It's got a negative in there, so it's an I. Square root of 9 is 3. So those are my two of my zeros right there. Add 5 to both sides. X squared equals 5. Square root both sides. So x is equal to plus or minus square root of 5. There's my other zeros. Those are my zeros. What do y'all think? Have you seen this? Okay, at least have you seen it before this semester? Yes. Everything we've done here, we've done numerous times before in chapter 3. Because to be honest with you, we've only introduced now cubic functions and using another method. That's the only thing new that we've had here. Everything else is the same. Once you factor them out, set them equal to 0, those give you your zeros. These are my factors that leads to my zeros. These are my factors that lead to my zeros. The zeros are my x-intercepts. These were my x-intercepts. That's it for section 1 of chapter 4. I was really hoping to do one more section, but oh well, we'll do that. Please, if you haven't even gotten to chapter 3 yet, start chapter 3 because you're going to need to know how to do that stuff for chapter 4. You'll need to know how to do factoring. You'll need to know how to do graphing of equations, polynomials. Please do that and start doing your homework.